Now, what was interesting about this whole business is I got into the business then of starting companies, and the first two we started, Applied Biosystems and Amgen, did exceptionally well. But I will say it's been one of the most rewarding experiences of my life to interact with people that live in a very different dimension from my own academic dimension. And one of the really interesting questions that I haven't still figured out is, how do you teach innovation? How do you teach thinking out of the box? And we do it really poorly in our schools. What was very interesting as I was in the process of developing the automated sequencer, as I was asked to the first ever meeting in the spring of 1985 on the Human Genome Project. This actually was done by my old chair, now Chancellor of Santa Cruz, Bob Sinsheimer, who wanted to start an institute to sequence the genome. So he called 12 of us experts to come and give him 2 days of discussion about whether this was a good idea. And the group came to two conclusions. One, it was possible, although challenging. I remember one of my friends saying to me, it's going to take you 100 years if it takes you a day to do the human genome. And what's interesting is he was right with the technology we had at that time. Where he was wrong is he didn't realize how exponentially technology is changing. So when you're skeptical about some of the things I say later in this lecture, keep that in mind. Anyway, the task of sequencing 3 billion nucleotides really seemed like an absolutely gargantuan one, and when several of us went out and started advocating this, I was shocked to find out how conservative most scientists were. NIH was against it. The 90% of the biologists were against it. It was big science. It was trivial. It wasn't going to give us any relevant kinds of information. And in fact, the real key to changing people's minds is you forget about the old ones and you convince the young ones, because they're much more susceptible to new kinds of ideas. But to make it work, and NIH did change its mind in accordance with a report by the National Academy of Science that said, of course, this should be done. We had to create a completely new institute at the National Institutes of Health, and it couldn't have got done if we'd had to impose it on one of the pre-existing institutes. Now, what was really interesting about developing the DNA sequencer is our initial efforts failed because I only used a biologist that had somewhat good engineering experience. And in the end, what I had to do was put together 4 different people, a chemist. Chemist turned out to be the most important in interesting ways, an engineer, a good molecular biologist, and a computer scientist. And within a couple of months of doing that, we'd conceptualized the invention, and it took another 2.5 years to realize it. But what that made me realize was that biology was going to be fundamentally changed in the future, and that it was of necessity going to have to become cross-disciplinary in nature. That is, we were going to have to bring together all of these different flavors of scientists in a collegial, interactive manner so they could focus on challenging technical and computational problems that modern biology was going to have. So I went to a different president of Caltech and said, I've got a terrific idea. Let's start a new biology department that is this cross-disciplinary, I called it, molecular biotechnology. And he said, well, it sounds kind of interesting. And again, it was just what you've heard before. The chemists and the engineers thought this was a great idea, and the biologists actually vetoed it. And that was the reason why in '92, fortunately, I got to know Bill Gates. He endowed our new department. We started the first cross-disciplinary department of molecular biotechnology, and it was spectacularly successful. And here's where serendipity plays a really interesting role. So the dean that I negotiated this move with agreed somewhat reluctantly, but he did agree that the department could be built in 2 phases. One phase was to create the cross-disciplinary foundational framework, and the second phase was to bring in systems biology. and these were to be staggered by 4 years or so. And unfortunately, at the end of the first 4-year period, when the cross-disciplinary department was really going extremely well, the dean died in an avalanche in the Himalayas, and the next dean that came on board had a very different view of biology and what it was all about. And that, in fact, was the reason that I decided to, in the year 2000, resign from the University of Washington and set up a nonprofit research institute to learn how to do systems biology. And what exactly is systems biology? Well, imagine what you'd have to do if you wanted to figure out how a radio converted radio waves into sound waves. The first thing you'd do is you'd do a parts list of that radio, and you'd assess the parts. You'd try and understand what they did individually, and this is what 40 years of molecular and cellular biology did. And the Genome Project did one very important thing. It gave us a complete parts list, and that's essential for systems biology. But the next thing you'd do is you'd assemble those parts into their circuits, and you'd learn how the individual circuits and their interactions with other circuits actually mediated the modulation of information to go from radio waves to sound waves. And it's exactly the same in biology. Biological information is mediated by biological circuits. And if you're to understand the deep and fundamental properties of biology, you'll never understand them by looking at one piece of a circuit, but rather you have to look at the system as a whole. And that's really the essence of what we're doing today, is we're taking a systems approach to these endeavors. The Institute is 6 years old now. We have about 180 people, 12 faculty members. We've put together the high throughput facilities and computational facilities that you need. But we've thought a lot about doing new ways of doing science and doing medicine, and I'm going to talk about those right at the end of my lecture. I will say parenthetically that you'll have to determine how relevant my experiences are to the kinds of opportunities you're thinking about here, but I believe fundamentally that there are many, many opportunities in a lot of the things I'll be talking about.